In today's lecture, we will answer all the questions given in Model Question Paper 2 of Mathematics for 2nd PUC. This is as per the reduced syllabus of academic year 2020-21. The total duration for answering these questions is 3 hours 15 minutes with a maximum marks of 100. The question paper has 5 parts, namely A, B, C, D and E, and you have to answer all the parts. Please note all the parts but not all the questions. You can use graph sheet for the question on the linear programming in part E of this question paper. Part A. In part A, there will be 10 questions and each question will carry 1 marks. Therefore, there will be total 10 marks and there is no choice. You have to answer all the questions. Examine whether operation star z plus 2z plus defined by binary operation a star b is equal to mod of a minus b, where z plus is the set of all positive integers, is a binary operation or not. You have to verify whether operation star of a star b is equal to mod of a minus b is a binary operation or not. Let us answer. Z plus denotes the set of positive integers, that is z plus is equal to n. Given on z plus, define a star b is equal to mod of a minus b. Let it be equation 1. We know that, say for example, take a is equal to 2 belonging to z plus and b is equal to 2 which also belongs to z plus. So we know the operation, binary operation a star b is equal to mod of a minus b. In this case will be 2 minus 2 is equal to 0, which is not a positive integer. Hence it does not belong to z plus. Therefore, this operation star is not a binary operation. That is, it does not satisfy the closure law. Question number 2. Find the domain of sine inverse of x. We know the domain of sine inverse x is minus 1, 1. Question number 3. Construct a 2 by 2 matrix whose elements are given by aij is equal to a plus j whole square divided by 2. This is to find each element of the matrix. So this is a lengthy answer. Please go through one by one step by putting different values of I and j. That is, I equals 1, j equals 1, I is equal to 1, j is equal to 2, and I is equal to 2 and j is equal to 1. So you will get 4 elements as shown below. Therefore, calculations are given and these elements will be 2, 9 by 2, 9 by 2 and 8. That is by putting one I as 1, j as 1, I as 1, j as 2, I as 2 and j as 2, and I equals 2 and j equals 2. You get the different values and you put it in a matrix. So therefore, A of the matrix A of the order of 2 by 2 is given by matrix Aij is 2, 9 by 2, 9 by 2 and 8. Question number 4. If A is a square matrix and adjoint of A equals matrix 5, 0, 0, 5, find determinant A, determinant of matrix A. Therefore, we know determinant adjoint A is equal to determinant A to the power of n by minus 1, where n is the order of the matrix. Therefore, determinant A is equal to determinant adjoint A, that is equal to 5, 0, 0, 5. So simplifying, we get 5 into 5 is 25, 0 minus 0 into 0 is 0. That is, the answer is 25. Next question. Differentiate cos of root x with respect to x. Solution: given cos of root x is equal to, we know dy by dx of cos of root of x is minus sine root x into differential of the inner part, that is differential of root x, that is equal to 1 over 2 root x. That is the answer. Question number 6. Evaluate integral of root of ax plus b. Therefore, put ax is equal to ax plus b is equal to t. Therefore, differentiating a into dx equals dt. That is differential of right hand side. That is equal to dx is equal to dt by a. Therefore, integrating both sides, we get integral of root t dt. This is root t dt divided by a equals integral of root t is power rule. That is integral of t to the power of half plus 1 divided by a constant into 3 by 2. That is equal to 2 into, simplifying, we get 2 into, again differentiating inner part, 2 into ax plus b whole to the power of 3 by 2 divided by 2a. Question number 7. Find the vector components of vector with initial point 2, 1 and terminal point minus 5, 0. So initial point is, you can take it as an origin 2, 1. That is the initial point, not origin, but 2, 1. X is 2, y is 1, and terminal point is y2 is minus 5 and x2 is minus 5 and y2 is 7. So let us find it. So integral PQ, if we take P as P, PQ is equal to x2 minus x1 into I, unit vector I, plus y2 minus y1 into j. Therefore, x2 we know is minus 5 minus 2 of unit vector I plus 7, that is y2 is 7 minus y1 is 1 minus 1 of j. That becomes minus 7i plus 6j. PQ is, therefore the vector components are minus 7 and plus 6. Next question. Find the distance of the plane 3x plus 3x minus 4y plus 12z is minus 3 equals 0 from the origin. So the initial point is origin here and the final point is given here. That is 3x minus 4y plus 12z minus 3 equals 0. Therefore, direction ratios of normal are, of these, direction ratios of normal are 3, minus 4 and 12. So we can find the square root of 3 square plus minus of 4 whole square plus 12 whole square, that is equal to 9 plus 16 plus 144, that is equal to square root of 169, that is equal to 13. Therefore, the distance can be calculated as, that equation can be written as 3 by 13, that we have to divide each coefficient of x 3 by 13 minus coefficient of y is minus 4 by 13 and coefficient of z is 12 by 13 equals, the right hand side is 3 by 13. So the distance is of the plane from the origin is 3 by 13, that is the right hand side. Next question. Define the objective function in a linear programming program. This is a definition, standard definition. You have to write whatever is given in the textbook. I will read for your information. Linear function z is equal to ax plus by, comma, where a comma b are constants, comma, which has to be maximized or minimized, is called the linear objective function. That is, z is a objective function where we have to maximize the values of x or y in case of profit, or we have to minimize the cost by minimizing x or y. Please write only the definition given in the textbook. Question number 10. If f is an event of a sample space S of an experiment, then find conditional probability of S given that f has already occurred. So the definition answer is conditional probability P of S upon f is given by P of probability of S intersection f divided by probability of f, that is equal to PF, probability of f divided by P of f equals 1. Here P of S intersection f is PF itself, because it is f is an event of a sample space itself. Let us now answer. Binary operation on R is defined by A star B is equal to A plus B by 2. Verify whether binary operation is associative. Solution. A star B within brackets star C is equal to, putting the values of A star B as A plus B by 2, we get right hand side is equal to within brackets A plus B by 2 star C. So simplifying, we get it as A plus B. But the associative properties also says A star B star C equals A star B plus C by 2. That is substituting the value of B star C as B plus C by 2. That is the given function. We get 2A plus B plus C divided by 4. That is not equal to the previous value A plus B plus 2C by 4. We know. So 2A plus B plus C by 4 is not equal to A plus B plus 2C by 4 in general. Hence, the binary operation A plus B by 2 is not associative. Next problem. Evaluate cos inverse of half plus 2 sin inverse of half. In this equation, we have to put the values of cos theta equals half and sin theta equals half. So that is cos inverse function will be cos inverse of half plus 2 into sin inverse of half, 1 by 2. That is equal to cos inverse 1 by 2 is equal to pi by 3 plus 2 into sin inverse of 1 by 2 is pi by 6. Simplifying, we get it as 2 pi by 3. Question number 13. Find the equation of the line passing through points 1, 2 and 3, 6 using determinants. Therefore, using determinants, we know area of a triangle is given by delta is equal to half into determinant x, y1, x1, y1, 1, x2, y2, 1. So substituting the given values in this determinant, we get area is equal to half into determinant of x, y, 1, 1, 2, 1, 3, 6, 1. Simplifying, we get 0. So area, because it is a line, the given line is a straight line, so area will be 0. Therefore 0 equals half into x into 2 minus 6 minus of y into 1 minus 3 plus 1 into 6 minus 6. We get the value as 2x. All other things get cancelled. Y is equal to 2x. That is the equation. Question number 14. Find dy by dx if ax plus by square is equal to cos y. Therefore, a into, we are taking ax plus by square, if we are taking the differential, we get a into dx by dx is 1 plus b into 2y into dy by dx is equal to minus differential of cos y is minus sin y into dy by dx. Therefore, segregating or separating the terms containing dy by dx, we get dy by dx into 2by, this coefficient, plus when it is taken on the left hand side, we get sin y equals this term containing a towards right side equals minus a. That is the equation for dy by dx is equal to a by minus of a by 2by sin plus sin y. Next question. Differentiate cos inverse of sin x with respect to x. Therefore, given function is y is equal to cos inverse of sin x. That is equal to cos inverse of, we can write sin x in terms of 90 minus x. That is cos of pi by 2 minus x. That is equal to cos of pi by 2 is pi by 2 minus x. That is equal to cos inverse of cos pi by 2 minus x is pi by 2 minus x. Therefore, now we will differentiate. Therefore, dy by dx is equal to dy by dx of pi by 2 is 0. That is a constant is 0. Minus d by dx of x is minus 1. That is equal to, or we get dy by dx is equal to minus 1 over 1 minus sin squared x, that into cos x. That is equal to minus 1 by cos x into cos x. That is equal to minus 1. This is the last step is an alternate method of finding the value. Otherwise, the answer ends here as dy by dx is equal to minus 1. This is an alternate method. We will continue with the next question. If y is equal to x to the power of sin x and x is greater than 0, find dy by dx. Therefore, put y is equal to x to the power of sin x. Therefore, taking logarithms, we get log y is equal to sin x into log x. Therefore, now taking the differential, we get differentiation of log y is 1 by y into dy by dx is equal to, this is the uv product, that is differential of uv, that is u into sin x into d by dx of log x is 1 by x plus log x, that is second function, into differential of the first function. Differential of sin x is cos x. Therefore, segregating the term dy by dx, we get dy by dx is equal to this denominator on the left hand side cross multiplied y into sin x divided by x plus log x into cos x. Question number 17. Find the local maximum value of function gx is equal to x cube minus 3x. This is a very important function. In the question paper, the question is given as x square minus 3x. If we take x square minus 3x and find the local maximum value, we will end up finding the minimum value. Hence, this problem I have corrected it here as gx is equal to x cube minus 3x, which is given in NCERT textbook. Solution. Given gx is equal to x cube minus 3x, g dash x, taking differential, g dash x is equal to 3x squared minus 3. Now we'll put g dash x is equal to 0 to get the turning point. So we have 3x squared minus 3x is equal to 0, or x is equal to plus or minus 1. So from this we will find the local minimum and maximum values. When we put, for that we will also calculate the second derivative, that is g double dash x of 3x squared minus 3, that is equal to g dash of 3x squared is, that is g double dash of x is 6x, that is equal to 6 of minus 1, that is the value we will take it as x is equal to minus 1 is minus 6. Now when we take x is equal to minus 1 from this equation, this is a local maxima, that is x is equal to minus 1 is a point of local maxima, and local maximum value is given by g dash of x, that is g dash of 3x square minus 3. So in this equation we put minus 1 whole cube in this equation, given equation, minus 1 whole cube minus 3 of minus 1, that is equal to 2. This is g of x. Please note this value is local maximum is g of x. So next is, therefore x is equal to, in the next step we will put x as 1. So which is a point of local minima, and local maxima is given by g of x, that is given equation g of 1 is equal to 1 cube minus 3 of 1, that is equal to minus 2. That is the answer. So we have found local maxima and local minima. Question number 18. Evaluate sine squared x minus cos squared x divided by sine squared x cos squared x dx. Here we have to segregate and separate sine squared x and cos squared x in the numerator. Let us do it, solve it. So separating, we get sine squared x by sine squared x cos squared x dx minus integral of cos squared x divided by sine squared x cos squared x dx. So in the first term sine squared x gets cancelled and we get 1 over cos squared x, minus integral cos squared x and cos squared x get cancelled, we will get 1 over sine squared x. So that is written here, that is integral 1 over cos squared x dx minus integral 1 over sine squared x dx. That is equal to, we know 1 over cos squared x is secant squared x dx minus 1 over sine squared x is cosecant squared x dx. Therefore, we know from the standard values of integral secant squared x is tan x minus of integral of cosecant squared x is minus cot x plus c is the constant of integration. That is the answer. So you write it one more step, tan x plus cot x plus c. Question number 19. Evaluate integral log to base e of x dx. Taking integration, we get uv function. It is uv function, that is equal to log e of x into integral of x is 1 dx. Therefore, log x integral, log x will take integral 1 of dx minus integral of dy dx of log x into integral 1 dx into dx. Therefore, that is simplifies as x integral dx is x log x minus integral of log dy dx of log x is 1 by x into x dx plus c. Taking integration, again we get x log x minus 1. This x gets cancelled. Integral of dx is minus 1 plus c. That is the answer. Question number 20. This is a very simple problem. Find the order and degree of differential equation. Here the differential equation is given. That is, the given differential is xy d squared y by dx squared plus x into dy by dx whole square minus y of dy by dx. If you examine this equation, we will get the highest order derivative is d squared y by dx and its power is 1. Hence, higher order is d squared y by dx square is 2. So, the order of the first different derivative is 2 and the power, its power is 1. Hence, the degree is 1. Hence, order is 2 and degree is 1. Next question. Question number 21. Find a vector in the direction vector A star. Vector A is equal to I minus 2j that has magnitude 7 units. Let us know. We know unit vector A is given by vector A divided by mod of A, vector A. That is, unit A is given as I minus 2j divided by mod of A is 1 square plus minus of 2 whole square. That is equal to I minus 2j divided by square root of 5. That is unit vector A. So now it is given as magnitude as 7 units. Hence we have to multiply A 7 times. Therefore it is 7 of A is 7 into mod of I minus 2j divided by square root of 5. That is equal to 7 by root 5 into I minus 2 by root 5 into j. That is the answer. Question number 22. Show that the vector I plus j plus k is equally inclined to the positive direction of axis. So, given vector is I plus j plus k. Therefore, mod of A is, modulus of A is square root of 1 square plus 1 square plus 1 square. That is coefficient of unit vectors I, coefficient of unit vector j and coefficient of unit vector k. That is equal to square root of 3. Therefore, direction cosines are 1 by root 3, comma 1 by root 3 and comma 1 by root 3. Therefore, cos alpha is 1 by root 3 and cos beta is 1 by root 3 and cos gamma is 1 by root 3. The given vector is, since the coefficient, the ratios, the coordinates are same, that is 1 by root 3 for all the three directional cosines, the given vector is equally inclined to the positive direction of axis. Question number 23. Find the Cartesian equation of the line that passes through the points 3, minus 2, minus 5 and 3, comma, minus 2 and 6. We have to find the Cartesian equations. Therefore, we know the equation, Cartesian equation is given by x minus x1 divided by x2 minus x1, that is equal to y minus y1 divided by y2 minus y1, that is equal to z minus z1 divided by z2 minus z1. Let us put the values of x1 and x2 from the given equation. Therefore, that becomes x minus x1 is 3. So, that is x1 minus x minus 3 divided by x2 is 3. 3 minus 3 equals y is y as it is, minus of y2 is minus of 2. Therefore, y minus of minus 2 divided by minus 2. Y2 is minus 2, minus y1 is minus of minus 2. That is equal to z minus z1 is minus pi, minus of minus pi divided by 6. That is z2 is 6 minus of minus pi. Now we simplifying, we get x minus 3 by 0 equals x plus 2 by 0 equals z plus pi by 11. This is the Cartesian equation of the line passing through the points 3, -2, -5 and 3, -2, -6. Next question. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. You know there are 26 black cards. So solution. A is equal to first drawn card is a black. So if the first drawn card is black, that means there are 26 black cards out of 52. So therefore, probability of A is equal to half. Therefore, conditional probability of B that already A has occurred. That is, already we have drawn a first black card. First drawn card is black. That is the probability. Conditional of the second drawn card black is 25. Because already we have drawn 1 out of 26. The remaining card is 25. And similarly, we have already drawn 1 card from the whole pack of cards. The remaining cards are 51. Therefore, the probability of B upon A is 25 by 51. Probability that both the cards are black is PA into P of B upon A. That is equal to 1 by 2 into 25 by 51. Next question. Question number 25. This is a part C question. Here a number of questions are given. You have to answer only 10 questions. Each question carries 3 marks. So total 30 marks for this part C. So now we will do question number 25. Show that the relation R in the set of all integers Z defined by R is equal to, within floor brackets, A comma B is equals to divides A minus B is an equivalence relation. So we have to prove R is reflexive. So as 2 divides A minus A for all values of A belonging to Z. Therefore, further, if A comma B belongs to R, then 2 divides A minus B. Therefore, 2 divides B minus A also equal. Hence, B comma A belonging to R, which shows that R is symmetric. So, first step is to prove it is symmetric. Similarly, if A comma B belongs to R and B comma C belongs to R, then A minus B and B minus C are divisible by 2. Now, we will take the next. A minus C equals A minus B plus B minus C are divisible by 2. Therefore, now A minus C is equal to A minus B plus B minus C is even. So, A minus C is divisible by 2. This shows that R is transitive. Thus, R is an equivalence in relation. So, we have proved that A is symmetric and transitive. Hence, R is equivalence. Question number 26. If A and B are symmetric matrices of the same order, then show that AB is symmetric if and only if A and B commute that AB equals BA. Since A and B are symmetric matrices, therefore A dash equals A and B dash is equal to B, because it is given that A and B are symmetric matrices. Let AB be symmetric, then AB whole dash is equal to AB. Let it be equation 1. Therefore, we can take individually AB whole dash is equal to individually A dash B dash is equal to BA. Let it be equation 2. Therefore, from 1 and 2, we have proved that BA is equal to AB. Conversely, we will take the next step. If AB is equal to BA, then we shall prove that AB is symmetric. Earlier, we have taken AB is symmetric. That is, we have taken A dash equals A and B dash equals B, and we have proved that AB whole dash is equal to B dash A dash is equal to BA. That is, BA is equal to AB. Now, if we take AB equals BA, then we shall prove that AB is symmetric. So, AB whole dash is equal to B dash A dash. Therefore, that is equal to BA, as both A and B are symmetric. That is equal to AB. Hence, AB is symmetric. Next question. Find dy by dx if x is equal to a into theta plus sine theta and y is equal to a into 1 minus cos theta. Solution. So, given x is equal to a into theta plus sine theta and y is equal to a into 1 minus cos theta. Therefore, dx of d theta is equal to, taking differentiation of x, we get a into d theta by d theta is 1 plus d by d theta of sine theta is cos theta. Therefore, for second term, dy by d theta is equal to a into d by d of minus cos theta is sine theta. Therefore, dy by dy by dx is equal to equation 2 by equation 1. That is, a sine theta divided by a into 1 plus cos theta. That is equal to, from the half angle formula, we know that it is tan theta by a gets cancelled. It is tan theta by 2. Question number 28. If x into square root of 1 plus y into square root of 1 plus x is equal to 0 for x lying between minus 1 to plus 1 and x is not equal to 0, prove that dy by dx is equal to minus of 1 over 1 plus x square. Therefore, rearranging the given equation, we get x into 1 plus square root of 1 plus y equals, taking this y term on the right hand side, we get x into square root of 1 plus y equals minus of y into square root of 1 plus x. Therefore, now squaring both sides, we get x square into 1 plus y whole square equals minus of y square, taking separately y square minus of y square x equals 0. That is equal to, taking x plus y common, we get x plus y into x minus y plus xy common, we get x minus y equals 0. Therefore, x minus y if we take common, we get x plus y plus x plus y equals 0. Therefore, x plus y plus xy is equal to 0. Because x is not equal to y, hence we get x plus y. X is not equal to y, we are taking only x plus y plus xy equal to 0. Therefore, y is equal to x divided by 1 plus x. That is, y is equal to minus of x divided by 1 plus x. Therefore, now we will take differentiation. Therefore, dy by dx is equal to, this is u by v formula we have to use. Therefore, that is equal to dy by dx is equal to v, that is 1 plus x into d by dx of x. That is minus we have taken inside, minus 1 minus This is minus of the formula, minus of x as it is into d by dx of 1 plus x is 1 divided by 1 plus x square. This is u by v formula. We getting this x, this minus x and plus x get cancelled. Only 1 remains in the numerator, that is equal to 1 over 1 plus x square, that is equal to right hand side of the question. Find the point at which the tangent to the curve y is equal to square root of 4x minus 3 under root minus 1 has its slope 2 by 3. Therefore, slope of the tangent to the given curve at x comma y is dy by dx is equal to, we take the differential of the given equation, half of 4x minus 3 to the power of minus half into 4 equals, simplifying, we get 2 divided by square root of 4x minus 3. Therefore, given this value is, given the slope is 2 by 3. Therefore, 2 by square root of 4x minus 3 is equal to 2 by 3. That is equal to 4x minus 3 is equal to 2 gets cancelled and we get 4x minus 3, that is denominator. Comparing the denominator, square root of 4x minus 3 is equal to 3, or 4x minus 3 is equal to 9, or x is equal to 3. That is 4x is equal to 6, 12, and x is equal to 12 by 4, that is equal to 3. Therefore, that becomes, now y is equal to square root of 4x minus 3 minus outside the square root of 1, that is equal to 4 into x is equal to 3, 4 into 3 minus 3 minus 1 is outside, 4 into 3 is 12, 12 minus 3 is 9, square root of 9 is 3, 3 minus 1 is 2. Therefore, y is equal to 2 is the answer. Therefore, the required point is 3, 2. That is, we have found x as 3 and y as 2. Therefore, point is 3, 2. Question number 30. Evaluate integral tan to the power of 4x dx. Therefore, tan to the power of 4x dx is equal to tan squared x into tan squared x. So that can be written as tan squared x into 1 tan squared x can be substituted as secant squared x minus 1 dx. That becomes integral tan squared x secant squared x minus tan squared x dx. Therefore, that becomes tan squared x secant squared x dx minus tan squared x dx. Therefore, tan squared x secant squared dx minus secant squared x dx plus 1 into dx. Therefore, now we have to put it as a substitute, solve it by substitution method. Put tan x is equal to t. Therefore, secant x, taking differential, secant x is equal to dt by dx. Or we can take secant squared x is equal to secant squared x dx is equal to cross multiplying, or secant squared x dx is equal to dt, because dx is dt by secant x. Therefore, that becomes tan squared dt. This is tan squared t squared. Secant squared dx is dt minus tan x plus c. So, integral of t squared dt is t cube by 3 minus tan x plus c. Therefore, now we have to put back the value of t as tan x. Therefore, we get tan cube x by 3 minus tan x plus c. That is the answer. Now 31. Evaluate integral of x divided by x plus 1 into x plus 2 dx. Therefore, given equation is written as it is. Therefore, that becomes x divided by x plus 1 into x plus 2 can be written as a over x plus 1 plus b over x plus 2. Therefore, that becomes x equals a into x plus 2 plus b into x plus 1. Therefore, comparing the coefficient of x, we get a plus b equals 1. That is, coefficient of x is a here and coefficient of x is b. Therefore, a plus b is equal to 1 and 2a plus b is equal to 0. And solving, we find equation value of a as a equals minus 1 and b is equal to 2. You do it yourself in the rough sheet. Therefore, the given equation becomes x over x plus 1 into x plus 2 becomes minus 1 divided by x plus 1 plus 2 divided by x plus 2. Therefore, taking integration, we get integral of x divided by x plus 1 into x plus 2 into dx is equal to integral of minus of integral 1 over x plus 1 into dx plus 2 into integral of 1 over x plus 2 dx. Therefore, we get integral of 1 over x plus 1 is log x minus log x plus 2 into log of x mod of x plus 2 plus c. That can be simplified as 2 into log of x plus 2 divided by x plus 1, or 2 into log of x plus mod of x plus 2 can be written as x plus 2 whole square. Hence, the answer is log of x plus 2 whole square divided by x plus 1 plus c. Question number 32. Evaluate sine 2x of dx. We know differential d by dx of cos 2x is minus 2 sine 2x. Therefore, dividing by minus 2, we get minus 1 by 2 d by dx of cos 2x is equal to sine 2x. Or d by dx of minus half 1 by 2 into cos 2x is equal to sine 2x. By definition, an integral of sine 2x is minus 1 by 2 into cos 2x plus c. Question number 33. Now this is also find the area of region bounded by the curve y is equal to x square and y is equal to 2. So this equation y is equal to x square is a parabola. This is the parabola touching x-axis at the point O. So you draw a parabola and the given equation line is y is equal to 2. Y is equal to 2 is a straight line parallel to x-axis, that is AB parallel to x dash x equal to 2. So this is the equation. Now to find the area of the given bounded by these two curves, we have to integrate definite integral a strip dy as the strip goes from the point 0 here to y is equal to 2. Y is equal to 0 is here at the point O and y is equal to 2 at the point N. Therefore, we will write it as 2 into twice. So, we will do it half and multiply. It is symmetrical about y-axis. So, hence it becomes 2 into integral 0 to 2 of y x into dy. So integral x into dy. Therefore, x is nothing but x is equal to square root of y. Therefore, we put That is the given equation equals 2 into integral 0 to 2 square root of y into dy. That when we simplified, we get 4 by 3 into y to the power of 3 by 2, limit is the lower limit 0 and upper limit 2. Therefore, if you put lower limit becomes 0, upper limit we get 2 into 2 to the power of 2 to the power of 3 by 2. So therefore, but 2 to the power of 3 by 2 is 2 into square root of 2. Therefore, that 2 into 4 becomes 8 by 3 into square root of 2. That is the answer. Question number 34. Solve y log y dx minus x dy equals 0. Given differential equation is y log y into dx minus x of dy equals 0. Therefore, y log y into dx is equal to x dy. Rearranging. Therefore, separating variables, that is dy by y log y is equal to dx by x. That is equal to integral dy by y log y equals integral dx by x. That is equal to put log y is equal to t. Therefore, the left hand side equation is 1 by y equals 1 by y is equal to dt by dy. And dy by dt, dy by y is equal to dt. Therefore, equation 1 becomes integral dt by t into right side is dx by x. Therefore, taking integration, we get log of mod of t is equal to log of x plus log of c. That is equal to log of xc, combining log of xc. Therefore, when t can be plus or minus, if we take mod xc is equal to t, or ax will be equal to, or that is equal to ax, where a is equal to plus or minus c. Therefore, y is equal to e to the power of ax, which is the required solution. Question number 35. Show that the position vectors of point P, which divides the line joining points A and B, having position vectors small a and small b internally in the ratio of m:1, is m into vector b plus n into vector a, whole thing divided by m plus n. Represented by the position vectors PA and PB respectively with respect to the origin. Let R divide AB internally such that M into AB equals N into AR. From triangles PRB and triangle PAR, we have vector RB equals vector PB minus PR. That is equal to B minus R. So B is here and R is shown here. Therefore, vector AR is also given by vector PR minus vector PA. That is equal to R minus A. Therefore, now we have M into vector M into B minus R equals N into vector R minus A. Therefore, rearranging and segregating terms containing M. Therefore, M into B plus n into a divided by m, m plus n equals r. So rearranging this equation, that is m into b minus r equals n into r minus a, we get r is equal to m into b plus n into a divided by m plus n. Hence the position vector of point r, which divides a and b internally in the ratio m and n, is given by PR is equal to m into b plus n into a divided by m plus n. Question number 36. Find the unit vector perpendicular to each of the vectors within brackets vector a plus vector b and within brackets vector a minus vector b, where a is equal to I plus j plus 1 k and vector b is equal to I plus 2j plus 3k. Let us solve it. So the given vectors a plus b is, adding a plus b, we get 1 plus 1 2i plus 1 plus 2 3j plus 1 plus 3 4k, that is a plus b is equal to 2i plus 3j plus 4k, adding the vectors a and b. And similarly, finding the result of vector a minus b, we get I minus I is 0, j minus 2j is minus j, and k minus 3k is minus 2k. So we have got vectors, sum of vectors a and b and difference of vector a minus b. So here the vector perpendicular to both these vectors is given by the cross product. That is cross product of a plus b within bracket into within brackets vector a minus b. That is given by determinant. Determinant is written as vertical lines. Unit vectors I, j, k, and second row is 2, 3, 4. That is this a plus b, 2, 3, 4. And a minus b in the third row, that is 0, minus 1 and minus 2. So simplifying, we get I, this is I into minus 6 plus 4, that is equal to minus 2i, then minus of j into minus 2 into minus 2, that is minus 4, that minus outside and this minus becomes plus 4j plus k into this plus k into minus 2 minus 0, that becomes minus 2k. So the cross product of a plus b into a minus b becomes minus 2i plus 4j minus 2k. Let it be a vector c. Therefore, taking modulus of this vector c, we get mod of c equals minus 2 whole square, that is 4, plus 4 square, that is 16, plus minus 2 whole square, that is plus 4. We get 24. That is, simplifying, we get 2 root 6. Therefore, the required unit vector is vector c divided by mod of vector c. That is equal to vector c is minus 2i plus 4j minus 2k. That is, it is given here in this line. Divided by mod of c. Mod of c is 2 root 6. That becomes minus 1 by root 6 into I plus 2 by root 6 into j minus 1 by root 6 into k. That is the answer. Next question. Question number 37. Find the distance between the parallel lines R equals I plus 2j minus 4k plus lambda into 2I plus 3j plus 6k, and another vector R is 3I plus 3j minus 5k plus mu into 2I plus 3j plus 6k. See, please see, this is of the form A1 plus lambda b, and this is A2 plus mu times b. B is common for both the lines because they are parallel. Given the two parallel lines are written as it is, A1 and A2. A1 is I plus 2j minus 4k, that is the first line, and A2 is 3I plus 3j minus 5k, and B is equal to common for the 2I plus 3j plus 6k. Therefore, the distance between the parallel lines is given by the formula. You have to remember this formula. D is equal to mod of or cross product of determinant of D is equal to determinant of B cross A2 minus A1 divided by mod of B. Please remember this formula. D is equal to B cross A2 minus A1 divided by mod of B, that is determinant. So determinant we can rewrite as determinant of ijk into B. B is 236. You see, B is 236 in second row, and A2 minus A1 we have to find out. A2 minus A1 is 3 minus 1 is 2. 3 minus 2 is 1. And again minus 5 minus of 4. That is minus of minus is plus 4. That is minus 1. Divided by mod of B. B is 2 square plus 3 square plus 6 square. Simplifying, we get mod of minus 9i plus determinant minus 9i plus 14j minus 4k divided by square root of 49. That simplifies to square root of 293 divided by 7. Next question. Bag 1 contains 3 red and 4 black balls, while bag 2 contains 5 red and 6 balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag 2. So we have selected the ball at random. So let us solve it. Let E1 be the event of choosing bag 1, and E2 be the event of choosing bag 2, and A2 be the event of drawing the red ball. Therefore, probability of E1 is equal to probability of E2, that is drawing ball from either bag 1 or bag 2 is 1 by 2 because there are two bags. Therefore, conditional probability of drawing a ball A, that is drawing a red ball from bag 1, that is red ball. A is red ball, probability of a red ball. So drawing a red ball is 3 by 7 because there are 3 red balls in bag 1. Hence, and total number of balls are 7. Therefore, it is the probability of drawing 3 red balls is drawing a red ball is 3 out of 7. Similarly, conditional probability of drawing a red ball from the back 2 is given by 5 divided by 11 because there are 5 red balls amongst a total of 11 balls in back 2. Now the probability of drawing a red ball from back 2 is being given that it is red is probability of E2 upon A. So by using Bayes theorem, we have the formula. This formula you have to remember, Bayes formula. Conditional probability of E2, that is E2 is drawing a ball from back 2 and A is the red ball, is given by the relationship probability of E2 into conditional probability of A upon E2 divided by probability of E1 into conditional probability of A upon E1 plus conditional probability of 2 into probability of A, conditional probability of A upon E2. That is equal to probability of E2 is 1 by 2 into probability of drawing a red ball from bag 2 is 5 by 11 divided by probability of E1 is half into conditional probability of A from E1 is 3 by 7 plus probability of E2 is half into conditional probability of A upon E2 is 5 by 11. The answer is 35 by 68. Next question, question number 39. Verify whether the function f of n to n defined by f of x is equal to x square is 1 on 1 on 2 and bijective. That means we have to test for 1 on 1 on 2 and bijective. So that is given is f. A given function f is such that n to n is defined by fx is equal to x square. Let us do it. Note, checking the injectivity is testing for 1 on 1 function, and checking the surjectivity is testing for on 2 function. So given function f is such that n to n is given by f of x is equal to x square. It is given, equation 1. Therefore, n is a domain and n is codomain here. So the first n is domain and second n is codomain. Therefore, now first is f is injective 1 on 1. So let x1, x2 belong to domain n such that f of x1 is equal to f of x2. Therefore, putting x is equal to x1 and x is equal to x2 in equation 1, we get x1 square is equal to x2 square. That implies x1 is equal to plus or minus of x2. Therefore, rejecting the negative sign because it contains all positive numbers only, that is n, hence because n are all positive, x1 is equal to x2. Therefore, f is injective, that is 1 on 1. Is f surjective or onto? Therefore, put f x is equal to 1 to etc. in domain n in equation 1. Therefore, the range is fx is equal to x square, that is x belonging to n. Therefore, 1 square, 2 square, 3 square, etc. should be 1, 4, 9, etc. Because f is equal to x square. F of x is x square. Therefore, we get the numbers 2, 3, 5, 8, etc. are not there in n. Therefore, do not belong to the range. Hence, f is not surjective. Therefore, f is injective but not surjective. Hence, f is not bijective also. Question number 4. If A is a matrix, column matrix 0, 1 and 2 and B is a row matrix 1, 5, 7, verify that AB dash is equal to B dash A dash. Now in this problem, we have to first find AB and then we have to find the inverse of AB. Then we have to find inverse of B dash and A dash. Therefore, AB is equal to, we will multiply, this is a 3 by 1 and this is 1 by 3. Therefore, we can multiply. Therefore, AB is equal to 0, 0 and 0. And second row we have 1, 5, 7. And third row we have 2, 10 and 14. That is 2 into 1, 2 into 5 and 2 into 7. Therefore, let this equation be 1. Now we have to find AB dash, that is transpose. Transposing, we get, that is changing the row by column. Therefore, it becomes AB dash becomes 0, 0, 0. That is first row becomes first column. Second row becomes second column. That is 1, 5, 7. And third row becomes third column 2, 10, 5. So we got AB dash. That is we got AB dash. Now we will try to get B dash. B dash is, that is in transposing 157. It becomes B dash becomes 157. That is column matrix. And A dash becomes 0, 1, 2. That is a row matrix. A dash is row matrix. Therefore, now we will find B dash into A dash. Please note B dash, A dash. Therefore, B dash is B dash into A dash is 1 into 0, 1, 2 and 0, 0, 5, 10 and 0, 7, 14. Let it be equation 2. Therefore, from this equation, now we get AB dash is 0. Therefore, AB dash is 0, 1, 2, 0, 5, 7, 0, 5, 7, 0, 7, 14. Hence, AB dash is equal to BA dash. Next question. Solve 4x plus 3y plus 2z is equal to 60. 2x plus 4y plus 6z is equal to 90. And 6x plus 2y plus 3z is equal to 70 by matrix method. A similar problem has been worked out in our regular video on matrix. Please refer it. There we have used the terms and more explanation is given, that is purchase of rice, wheat and onion on different conditions. Please refer it, and this is a concise part. Only we are starting this from the equations. Let us start. Given 4x plus 3y plus 2z is equal to 260, 2x plus 4y plus 6z is equal to 90. 6x plus 2y plus 3z is equal to 70. You write down as it is. So we are writing it in the form, rearranging in the form, that is 4, 3, 2 equals 60 on the right hand side. 2, 4, 6 equals 90 on the right hand side. 6, 2 and 3 into z, that is equal to 70 on the right hand side. And since the matrix is 4, 3, 2, 2, 4, 6, 6, 2, 3 into x, y, z, that is a column matrix, is equal to, on the right hand side, 60, 90 and 70. We have to test it initially. Ax is equal, this is of the form Ax is equal to B. A, x and this is B. So, where A is this, B is this one and C is last, that is right hand side. That is Ax. Ax is equal to B. B is the column on the column matrix on the right hand side. So, we will rewrite it and simplify. A is equal to, we will test 4 into, that is matrix A is tested as a determinant. 4 into 12 minus 12 minus of 3 into 6 minus 36 plus 2 into 4 minus 24. That becomes 90 minus 40, that is equal to 50, and it is not 0. Hence, it is not 0. Hence, is a non-singular matrix. Now, that means non-singular means A inverse exists and unique solution is given by X is equal to A inverse of B. So, we will get the solution in the form X is equal to A inverse B. Therefore, we will calculate each element of the matrix or determinant as given below. So, it is A11. A11 is equal to 12 minus 12 equal to 0. Then A12 is minus of 6 minus 36. So similarly, we can calculate all other elements A13, A21, A22, A23, A31 and A32, and we are calculating that as given, as shown here. That is, adjoint of A is given by 0, 30, minus 20, minus 5, 0 and 10, and 10, minus 20 and 10. These are the calculation. That is, we are required to calculate adjoint. Now we have found the matrix. So adjoint is inverse of that. That is, we have to transpose this matrix. So transposing, we get row into column. 0, 30, minus 20. That is, first row becomes first column. Second row, minus 5, 0, 10 becomes second column. Minus 5, 0 and 10. The third row, that is 10 minus 20, 10. It becomes third column. 10 minus 20, 10. So now this is adjoint of A. Adjoint of matrix A. Okay. Now the solution is X is equal to A inverse of B. Inverse of matrix is X, that is, we will rearrange X, Y, Z, the variables on one side is equal to, inverse is mod A. Mod A is 50. 1 over 50 into adjoint of A. Adjoint of A is written as it is. We have copied it. Adjoint of A into B is the right hand side matrix. That is 60, 90, 70. So we have written the equation X is equal to A inverse of B. A inverse is nothing but adjoint of A divided by mod of A. So rearranging, we get 1 by 50 into multiply with each. So we get 0 minus 450. That is 50. 1 by 50 into 0 minus 450 minus 700. That is 0 into 60 minus 5 into 90 plus 10 into 70 in the first row. And in the second row, we get 30 into 60, 0 into 90 and minus 20 into 70. So that is 1800 plus 0 minus 1400. Similarly, in the last row, minus 20 into 60 is minus 1200, 10 into 90 is 900, plus 10 into 70 is 700. So this becomes 1 by 50 and totaling we get 250, 400 and 400. Now we will divide it by 50. We get, if we divide it by this 50, X, Y, Z is equal to 250 by 50 is 5, 400 by 50 is 8, again 400 by 50 is 8. Therefore, X is equal to 5, Y is equal to 8 and Z is equal to 8 is the answer. Now we will go to the next problem, 40. Next question. If y is equal to e to the power of a cos inverse x, where x lies between minus 1 and plus 1, then prove that 1 minus x square into y2 minus x y1 equals minus a squared y equals 0. 1 minus x square into y2 minus x into y1 minus a squared y equals 0. Let us solve it. Given the given equation, y equals a to e to the power of a cos inverse x. Let it be equation 1. Then we will differentiate. Therefore, dy by dx is equal to e to the power of a cos inverse x into d by dx of the power, that is d by dx of a cos inverse x. So, because d by dx of e to the power of fx is equal to e to the power of fx into d by dx of fx. Or we can write dy by dx is equal to e to the power of a cos inverse x into differentiating this within bracket a into minus 1 over square root of 1 minus x square. That when simplified becomes minus a into e to the power of cos inverse x divided by the denominator square root of 1 minus x square. Or cross multiplying, we get square root of 1 minus x square into dy by dx is equal to minus of a into e to the power of a cos inverse x. So that is nothing but minus a into y, because y is e to the power of a cos inverse x. Let it be equation 2. Differentiating again, because we are required to find out y2, we get square root of 1 minus x square into d square y by dx square plus dy by dx of this 1 by 2 into 1 minus x square to the power of minus half into dy by dx, that is d by dx of 1 minus x square equals minus of a, right hand side, a into dy by dx. Therefore, that becomes square root of 1 minus x square into d squared y by dx squared plus half into dy by dx of 1 by square root of 1 minus x square into differential of minus 2x into differential of minus 2x. That is equal to minus a into dy by dx. Multiplying by LCM. LCM is 1 square root of 1 minus x square. That is here in this part. We get 1 minus x square into d squared y by dx square. That is the first term, minus of the 2 gets cancelled and it becomes x into dy by dx, because LCM has been taken, and equals right hand side also we have to multiply, that is minus a into square root of minus 1 minus square root of 1 minus x square into dy by dx. That is multiplying both left side and right hand side by square root of 1 minus x square. That becomes within bracket 1 minus x squared into y2 minus x into y1 equals minus of a into within brackets minus of ay, that is equal to ay square. That is, this term becomes ay square. Therefore, simplifying, we get 1 minus x square into y2 minus x y1 minus of ay square that is equal to 0. That is the required equation. Next question. A particle moves along the curve. If 6y is equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as x coordinate. So given equation is written 6y is equal to x cube plus 2, that is, let it be equation 1. Now we differentiate this equation, we get dy by dx is equal to 8. It is also given that the y coordinate is changing 8 times. Therefore, dy by dx is equal to 8. Now we differentiate the equation 1. Therefore, 6 into dy by dx is equal to 3x squared. Therefore, now put dy by dx is given as 8. Therefore, put dy by dx is equal to 8. That is 3x squared is equal to 6 into 8. That is 48. Or simplifying, we get x is equal to plus or minus 4. Please work out in detail. When x is equal to plus 4, y is equal to x cube. That is 4 into 4 into 4, 64 plus 2 divided by 6, that is equal to 11. Therefore, when x is equal to minus 4, y is equal to x cube, that is minus 4 whole cube is minus 64 plus 2 divided by 6, that is equal to minus 31 by 3. Therefore, the required points are x is 4, y is 11. The first point. And the second point is x is minus 4 and y is minus 31 by 3. These are the x and y coordinates. Next problem. Find the integral of 1 over x square minus a square with respect to x and hence evaluate integral of 1 over 4x square minus 9. This is a standard derivation for the formula 1 over x square minus a square. This is also given in the textbook. So we will repeat it step by step. Put 1 over x square minus a square is equal to 1 over x minus a into x plus a. That becomes integral, if we take integral of 1 by 2a into x minus a into x plus a, it becomes x plus 1 over 2a into 1 over x minus a minus of 1 over x plus a. So therefore, now integrating, sorry, integration is not there. It was the previous equation of multiplying and dividing. So that becomes integral of dx divided by x square minus a square equals 1 over 2a into integral of dx by x minus a minus dx integral of dx by x plus a. That is equal to 1 over 2a into log of x minus a, log of mod of x minus a minus log of mod of x plus a plus c, that is the right hand side. That is equal to 1 by 2a into log of x minus a over x plus a plus c. So now we have to find this is the standard formula, that is integral of 1 over x square minus a square is equal to 1 by 2a into log of mod of x minus a over x plus a plus c. Now we have to evaluate integral of 1 over 4x square minus 9. Here x is equal to 2x. So put 2x is equal to t or 2 dx is equal to dt. That becomes integral of this equation becomes integral 1 over t square minus 3 square into dt by 2 because dx is equal to dt by 2. So that is dx is equal to dt by 2, that is equal to half of this 2 is taken out, half of this formula, standard formula 1 by 2a, 1 by 2 into 3 into log of x minus a, t minus 3 divided by t plus a plus c. Now we will put back t is equal to tx. Therefore, it becomes the given equation 1 by 12. That is 2 into 2 into 3 is 1 by 12 into log of 2x minus 3 divided by 2x plus a plus c. That is the answer. Next question. Find the area of ellipse x square by a square plus y square by b square is equal to 1, where a is greater than b by the method of integration. We are required to find the area of ellipse whose equation is given as x square by a square plus y square by b square is equal to 1. Let us start. Now from the figure, please see the figure. The figure is shown here. X and x dash x is the x-axis and y dash is the y-axis. It intersects at the point O. And with point O, we take A as the principal axis of ellipse A. A, B dash is an ellipse where the coordinates of x is A0. The A is A0, that is capital A is small a comma 0 and capital B is 0 comma B, that is x is 0 here, y is B. Similarly, A and 0 minus A here, A dash is minus A0 and B dash is 0 minus B. Please write here minus A. Okay. Now we have to consider the quadrant BOA and take a strip. Now I will start solving. From the figure, the area of the region AB A dash B dash A bounded by ellipse is equal to 4 times integral 0 to a y dx. So this is y, strip is y into dx is the width of the strip and y is varied from 0 to a. So this is the equation of y. We have to put the value of y in terms of equation. Therefore, x square by a square plus y square by b square is equal to 1. That is rearranging and finding the value of y. Y is equal to minus of x square by a square minus 1. So that becomes plus or minus b by a into square root of a square minus x square. You please rearrange and find the value of from this equation as y is equal to plus or minus b by a into square root of a square minus square. So region AOBA, that is the shaded portion of the blue color, AOBA is the first quadrant. In the first quadrant, y is taken as positive. So the required area is integration of 4 times y value is plus or minus b by a into a square minus x square dx. We know from our knowledge the standard integration is given by the right hand side equation. That is integral of square root of a square minus x square dx is given by equals x by 2 into square root of a square minus x square plus a square by 2 into sine inverse of x by a. This formula you have to remember as the derivation integration of the left hand side. So substituting, we get 4b by a into x by 2 into square root of a square minus x square plus a square by 2 into sine inverse of x by a with limit 0 to a. Lower limit is 0, upper limit is a. Now substituting, we get 4 by a into x by 2. The upper limit is a. Therefore, a by 2 into a square, x if you put a square minus a square becomes 0. The whole term is 0. Then again we are putting the upper limit, that is a square by 2 into sine inverse of a by a. A by a gets cancelled, sine inverse of 1. Therefore, it is a square by 2 into sine inverse of 1. Sine inverse of 1 is pi by 2. So, substituting, we get 4ab 4a. This a and this a gets cancelled. That becomes 4ab. ab is b square by 2 into pi by 2 is the answer. 4ab by, and now we further if we simplify, it becomes pi ab. Next question. Solve the differential equation x dy by dx plus 2y is equal to x squared log x. Therefore, the given differential equation is x into dy by dx plus 2y equals x square. That becomes, now we have to divide both sides by x. Divide by x. Therefore, the given differential equation becomes dy by dx plus 2 by x into y equals x log x. That is, x square by x is x log x. Now again, it is of the form, in standard form, dy by dx plus py into py equals q, where the integrand function equals e to the power of p dx. Now we have to find p is equal to, here you see, comparing the equation, p is equal to 2 by x and q is equal to x log x. So integrating, we get integral p dx is equal to 2 log x. These are the details we have worked at in our regular video. Please go through it. So that becomes integrating function is equal to e to the power of log x square, because e to the power of log fx is equal to fx. Therefore, the general solution is given by y into if. Integral to if equals integral of q into if dx plus c. So, if you substitute, we will get y into x square. This is the x square. If is x square into integral x log x into x square dx plus c. That is equal to integral x cube. X into x square is x cube written here, log x dx plus c. Now that becomes log x into x to the power of 4 by 4 minus integral 1 over x into x to the power of 4 by 4 dx. That becomes yx square is equal to x to the power of 4 by 4 log x minus x to the power of 4 by 16 plus c. Therefore, now again dividing by x square, y is equal to x square by 4 log x minus x to the x square by 16 plus c by x square. Again the constant changes, y is equal to x square by 16, taking common, 4 log x minus 1 plus c by x square. That is the general solution of the given equation. Question number 47, we will take up in the full slide. It will appear in the next slide as 47. Now we will take up question number 48. Two balls are drawn at random with replacement from a box containing 10 black and 8 red balls. Find the probability that both balls are red. First ball is black and second is red, and one of them is black and other is red. Since two balls are drawn with replacement, the two draws are independent. Therefore, the number of black balls is equal to 10 and number of red balls is 8. That is given. Therefore, total number of balls equals 18. First question is when the case of both balls are red. That is probability both balls are red is equal to probability that first ball is red and second ball is also red. Therefore, probability, that is probability of first ball is red into probability of the second ball is red. So that becomes 8 by 18. That is probability of first ball red is 8 by 18 and second ball is also 8 by 18. That becomes, simplifying, 16 by 81. Now second ball, that is first ball is black and second is red. That is equal to probability of the first ball is black into probability that second ball is red. So that is the number of black balls are 10. Therefore, P of first ball black is 10 by 18. The number of red balls are 8. Therefore, that is equal to 8 by 18. Simplifying, we get 20 by 81. So now the third problem. One of them is black and the other is red. Probability that one of them is black and the other red is given by probability that first ball is black and second ball is red, or probability the first ball is red and second ball is black equals probability that first ball is black and second ball is red plus probability. Here you see plus, and the first ball is red and second ball is black. That is given by probability of first ball is black and probability of second ball is red plus probability first ball is red into probability of second ball is black. Therefore, that is equal to 10 by 18 into 8 by 18 plus 8 by 18 into 10 by 18. That is equal to 20 by 18 into 20 by 81. Sorry, this is 20 by 81 into 20 by 81. That is equal to 40 by 81. Question number 47. Derive the equation of the plane in the normal form, both in vector and Cartesian form. This is also a standard derivation. So, solution is given in the textbook. Please go through it. Consider a plane whose perpendicular distance of origin is d. If yn is the normal from the origin to the plane and n unit vector is the unit normal vector of yn, then yn, vector yn is equal to d into, that is the distance into unit vector. Let P be the any point on the plane, then NP is perpendicular to ON. See here, this is O, this is a plane, the three coordinates X, Y and Z, and this is one plane X, Y, Z, and P is a point on the plane and N is the ON is the normal. Therefore, NP is perpendicular to ON. NP, this is perpendicular to ON. Therefore, NP dot ON equals 0 because they are 90 degrees. Therefore, let R be the position vector of point P. Then NP is equal to vector OP minus vector ON. That is equal to R minus D into N. Therefore, from equation 1, R minus D into N equals into D into N equals 0. Therefore, but D is not equal to 0. Therefore, R minus D into N into vector N, unit vector N equals 0. Or R minus N into D of N into N equals 0. But N into N is 1. Therefore, Rn is equal to vector R into unit vector N minus D equals 0. Therefore, from this Rn is equal to D, where D is the perpendicular distance from the origin. Let Mn be the direction cosines of unit vector N. Therefore, N is equal to Li in plus Mj plus Nk, and OP, that is OP is vector R is equal to Xi plus Yj plus Zk. You have to remember, practice it and remember. Therefore, R dot N is equal to D. And it can be written as the equation of vectorial form Xi plus Yj plus Zk into Li plus Mj plus Nk is equal to D. Therefore, Lx plus My plus Nz equal D is the Cartesian equation of the plane in the normal form. This is the standard derivation. You please go through it and practice. Now we go to part E. In part E, two questions will be asked. That is question number 49 and 50. 49 will have two parts, A of 6 marks, and part B will have a question, part B will have a question of 4 marks. So you can either answer 49 or 50. Let us solve both. First, prove that integral A to B of f of x is dx is equal to integral A to B of a plus b minus x into dx, and evaluate integral pi by 6 to pi by 3 of dx divided by 1 plus square root of tan x. This is a 6 mark question and standard derivation. It is the property of definite integrals. Therefore, consider integral a to b of a plus b minus x of dx. Therefore, put a plus b minus x is equal to t. Therefore, integrating, we will get minus dx is equal to dt. Therefore, put x is equal to a. Therefore, x is equal to a. At x is equal to a, t is equal to b. That is, if you put x as a, t will be equal to b. And if you put x as b, then t will be equal to a. So, therefore, there is a change in limit. That is, lower limit becomes upper limit. Therefore, right hand side will be equal to integral a to b of ft minus dt becomes integral b to a of ft dt, because here dt has changed. Therefore, integral a to b of fx is equal to left hand side. Now consider the given equation integral pi by 6 to pi by 3, that is dx pi by 3 of dx by 1 plus square root of tan x. That becomes integral of pi by 6 to pi by 3 of, we have to substitute for the value of tan x and dx. If we find that, we will get square root of, this is the given by the relationship, square root of cos x divided by cos x plus square root of sin x dx. Therefore, let I is equal to integral pi by 6 to pi by 3 of square root of cos x divided by square root of cos x plus square root of sin x dx. This let it be equation 1. Now applying the formula, integral a to b of f of x dx is equal to integral of a to b of f of a plus b minus x into dx. So now we get upper limit. So it will be integral of pi by 6 to pi by 3 of, we can write it as cos of pi by 6 plus pi by 3 minus x divided by square root of cos of the denominator x, pi by 6 plus pi by 3 minus x plus square root of sine of pi by 6 plus pi by 3 minus x. Therefore, let us write it as I, because cos we are simplifying it as I is equal to pi by 6 of pi by 3 into square root of sin x divided by sin x plus cos x into dx. Therefore, adding 1 and 2, we get 2i, I plus I, that is, here is 1i and this here second I. 2i is equal to integral of pi by 6 to pi by 3 of cos x plus sin x. Add simply equation 1 and 2 we have written here. Then that becomes simplifying cos x plus sin x divided by the same denominator into dx. Therefore, that is equal to 2i into integral of pi by 6 to pi by 3. Cos x plus sin x in the numerator and denominator gets cancelled, only dx remains. Therefore, 2i is x, integral of dx is x with the same limits, pi by 6 to pi by 3. Now we will put the limits. So upper limit if you put pi by 3 and minus lower limit is pi by 6. That becomes pi by 6. That is the answer. So therefore, I is equal to pi by 6, pi by 12, because 2 into 6 is 12. So I is equal to pi by 12. Next question, 49b. Find the values of a and b such that the function defined by fx is equal to ax. Fx is equal to 5 if x is less than b, when x is less than or equal to 2. Fx is equal to ax plus b if x is less than 2 but b lies between 2 and 10, and fx is equal to 21 if x is greater than 10. We have written the given equation as it is. From 1, 2 and 3, fx is defined as x less than or equal to 2u, that is into 2 between x less than 10 is x greater than for f is equal to fx is defined for x is less than or equal to 2 intersection 2 less than or x less than 10 union x is greater than or equal to 10, that is for minus infinity to 2 1 union 2 to 10 union 10 to infinity, that is for minus infinity to infinity, that is on R fx is R. Therefore, it is also given that f of x is continuous function. Of course, its domain here is R. Therefore, f of x is also continuous at the partitioning point. Please note, partitioning point is 2 and 10 here of the domain. Therefore, because fx is continuous at the partitioning points, that is x is equal to 10, therefore left hand side limit of f of x is equal to right hand limit of f of x is equal to f of 2. That is the partitioning point. And then limit of f of x, left hand limit of f of x equals left hand limit of limit of 5, that is substituting the value of x. Therefore, putting x is 2 comma 5, we get again limit of right hand side limit of f of x equals limit of ax plus b. It is given here, right hand limit, that is equal to f of x, putting x is equal to 2. Therefore, that is the lower limit. X is equal to 2 is 2a, ax plus b, 2a plus b. Therefore, putting x is equal to 2 in equation 1, we get f of 2 is equal to 5. Therefore, putting these values in equation 4, that is limit of f2. This is limit equation 4. We get 5 is equal to 2a plus b. That is equal to 5. Therefore, 2a plus b is equal to 5. Equation 5. Again, at x is equal to 10, we get left hand limit of 10 minus is f of x is equal to limit of right hand limit of f of x. That is equal to f10. Let it be equation 6. Therefore, now limit of left hand limit of f of x is equal to limit of left hand limit of ax plus b. Therefore, at x is equal to 10, that is 10a plus b, we get the right hand limit of f of x equals, if you add here, 10 into 2, 20 plus 1, 21. Putting x is equal to 10 in equation 3, that is here x is equal to 10, we get f of 10 is equal to 21. Putting these values in equation 6, we get 10a plus b is equal to 21. Solving 5 and 7 for a and b, we get a is equal to, that is 5 and 7, 2a plus b is equal to 5, 10a plus b is equal to 21. We get a is equal to 2 and b is equal to 1. Solve the following linear programming problem graphically. Minimize and maximize. Please note, minimize and maximize z is equal to x plus 2y. This is z is equal to x plus 2y is the objective function. Subject to constraints x plus 2y greater than equal to 100 and 2x plus y less than or equal to 200 and x comma y is equal greater than or equal to 0. So let us solve it. So x comma y greater than 0 shows that we have to plot the graph. The limits are in first quadrant. Therefore, three equations, constraint equations are written down as x plus 2y equal to 0, 2x minus y equal to 0, and 2x plus y equal to 200. So, these three are constraint equations. Let us write a table for this and calculate. We will get 2 points x and y for drawing the graph line, equation of the, for drawing the line. So, therefore, x is 0. The first line is x is 0, if y is 50. When y is 0, x is 100. In the second equation, when x is equal to 0, y is 0. And when x is equal to 20, y is 40. These relations are given in the table 2. The next is 2x plus y is equal to 200. So when x is 0, y is 200. And when y is 0, x is 100. So we have got 2 points for each of these lines. Therefore, that can be designated as written as D 050, E 100 0, O 00. This is origin. 00 is origin. A point A 2040, C 0 200 and E 100 0. Therefore, now we will draw the graph of these constraints equation and identify the feasible region. You have been taught about writing the graph. So select first point is write x-axis and y-axis. So select a proper scale. Highest value of x is 100. So therefore x-axis you mark 0 to 100 as shown in the graph. These are the x variables. And in the y-axis you write 0, 50, 100, 150, 200 and 250. This is the y-axis. And this is the point 0, 0. So here x is 0, y is 0. So draw the first line D and E equals 0, 50 and 100, 0. So this is the equation. First line 2x plus 2y. You write the points coordinates, so mark the points D and E and join them to get this blue line DE. X plus y is equal to 200. Next line is 2x minus y is equal to 0. That is a pink colored line with coordinates 0, 0 and A 20, 40. So we'll get this point 0, 0 and 20, 40 here. You join these 2 points and extend it up to this point to get the line 2x minus y equal to 0. And the third line is 2x plus y is equal to 200. Its coordinates are C and E. E already we have marked 100 as 0 in the first line. It coincides with that, and only point you write as C as 0. For x is 0, y is 200. So this is point C. So join C and E to get the third line. Now you have got 3 lines DE, AB, that is OAB and CE. These 3 points are drawn in the graph line. So now we have to mark the feasible region. Examine that. The third line 2x plus y should be less than or equal to 200. So 2x plus y is less than 200 is here only. So this is the feasible region. You please shade the feasible region. That is DA, BC, D is the feasible region. You please mark it and note down the coordinates of D, A, B, C, D, and that will be written as the vertex point. So coordinate of A is 20, 40. Coordinate of B is 50, 100. That is 50, 100. Coordinate of B is 50, 100. Coordinate of C is 100, 0 to 100. And coordinate of D is 0, 50. These are known as vertices. For each value of x and y in these equations, calculate the objective function. We know objective function is z is equal to x plus 2y. That is given. So put z is equal to x plus 2y. That is 20 plus 2 into 40. That is 100. And then z Z is equal to, at point B, Z is equal to 50, X is equal to 50 plus 2 into 100, that is 200. The value is 250. At point C, Z is equal to 0 plus 2 into 200, that is equal to 400. Similarly, at the point D, X is 0 and Y is 50. Therefore, Z is equal to 0 plus 2 into 50, that is equal to 100. Now you compare the values here. The minimum value is 100, which is appearing twice. So 100 at A and 100 at D are the minimum value points. And maximum point, if you want to observe, if you see, maximum is 400. So 400 at X is equal to 0 and Y is equal to 200. That is, at the point C is the maximum value. You write down the same relationship. So that is from the above table. We observe that minimum value of Z is 100 and it corresponds to A 20, 40, that is X and Y, and D is equal to 0, 50. And maximum is, from the above table, we observe that maximum value is 400, corresponds to X is 0 and Y is 200. This solves your problem. Now we will go to 50th B. The given matrix is A is equal to 2, 3, 1, 2. Therefore, that is satisfies the equation A square minus 4A plus I equal to 0, where I is equal to 1, 0, 0, 1 and O is 0, 0, 0, 0, and find A inverse of E. Therefore, now multiply the given matrix A into A. Therefore, 2 into 3, 1 into 2, 2, 3, 1, 2. That becomes 2 into 2 is 4 plus 2 into 1 is, that becomes A into A. If you multiply, 2 into 2 is 4 plus 3 into 1 is 3. That is 7. Then 2 into 3 is 6 plus 3 into 4 is 12. Therefore, 7, 12. That becomes A into A becomes 12, 7, 12, 4 and 7. That is first row into first column and then second row into second column. That if you multiply, you will get 7, 12, 4, 7. Therefore, A square is 7, 12, 4, 7 minus 4A, 2, 3, 1, 2, minus 4 into 2, 3, 1, 2 plus 1, 0 and 0, 1. Therefore, that becomes 7, 12, 4, 7 minus 8, 12, 4, 8. That is multiplying by 4 plus 1, 0, 0. That becomes, if you add all this, 7 minus 8 plus 1 is 0. 12 minus 12 plus 0 is 0. And 4, 4 plus 0 is 4 minus 4, 0 is 0. 7 minus 8 plus 1 is 0. Therefore, this is 0. Therefore, A square minus 4A plus I equals 0, or A square minus 4A is equal to minus I. Therefore, AA into again multiplied by A inverse, that is equal to A inverse into 4 of A into A inverse, that is equal to minus of A into A inverse matrix. Therefore, A, taking A common, A into A minus 4I equals minus I into A inverse. That becomes A into A is 1. Therefore, AI is I minus 4I equals minus A inverse. Therefore, A inverse is equal to 4I minus A. That is equal to 4 into 4, 4004 minus 2, 3 and 1, 2. Simplifying, we get A inverse is equal to 4 minus 2 is 2, 0 minus 3 is minus 3, 0 minus 1 is minus 1, 4 minus 2 is 2. This is the answer.